I am on the video circuit, so that must mean we're about to release 4.2. It's jam-packed full of features, and I'm going to cover some of those, and other team members will also fill in with videos. But in this video specifically, I want to talk about parameter passing and how that's changed in 4.2. Now, if you're not a prior user of HighByte, you can probably skip this video. I think you're going to love the new way. It's intuitive. You'll just run with it. If you're a past user, this video is, I think you're going to love it as well, but this video is more to show you kind of what we did, what that migration is like, so you don't get any surprises. And then, and most of that migrations are done for you, so don't worry about that. We didn't create work for you. But what that looks like and more why we did it. So to do this, I've got two versions of HighByte, 4.1 and 4.2. I'm going to run them side by side so we can see exactly what happened or what changed. So if you're a prior user of HighByte, you're probably familiar with templating and parameter passing. So in here, I've got an example of an OPC input that I parameterized, which means that when I call this, someone's going to pass in a line ID and control which line I'm reading. Now to do that in 4.1, what you do is you turn on templating, you define the line ID, and then you define the pattern. In this case, I'm just defining a default value. And when we read, that one gets substituted in, and you're good. Now you could also templatize this, which means you're going to define inside this definition, variants of it, so 10 values. And then when I read this, well, one of those failed. I think ignore the bad quality ones. Nope. I think there's only two. Let's try that. Yes. All right. So you get an array, and you can't see the whole thing, but two of them. So I read two branches essentially because of templating. And that's the 4.1 format for doing it. Now, when you go to use this in 4.1, I've got an instance that does the same thing. So it creates a parameter, and then inside the attribute expressions, you can see this is a string syntax we've used for a long time to pass that parameter. So I'm saying, hey, go call the OPC input, give it a line ID of the line ID that's coming from this definition, so 1, and then index into the alarm reason. And this is what it looks like for references. It looks the same for expressions, and you test that, and you get the result. Now in namespaces, I got two more levels here to show you the way it worked before. In namespaces, here I'm referencing that instance, so I brought in the mixer, and here to control the parameter that I'm passing to the mixer, in a namespace you'd write JSON, right? So this is a little different. It worked, right? I can read mixer 1 or mixer 2. I can control that at this level, but it's, it was a different syntax. It was kind of a first pass to get that to work. And lastly, if I created a pipeline and I wanted to reference that instance, here I have mixer UNS. What I've done here is every once a minute this is firing and it's reading the mixer, and if you look at the configuration here, it's that same kind of syntax. We're saying, hey, pass the line ID, give it a value of 1, and that'll be mixer 1. And then in this case, I'm writing this out to the UNS. I also have one down here that's reading the namespace. That's not using any parameterization, but so that's how we would handle parameters. And the last one I have in here we'll look at as well is this was in 4.1 an API. So what I've done here is I've created an API endpoint by marking this callable. This pipeline is exposed through our REST API. In this read stage, we're passing and this is where it starts to get ugly, especially when you get multiple parameters. This string syntax that says set the line ID to something coming in from the event value. So the caller is going to pass in a line ID, and I'm going to return. And this worked, right? But it was just kind of a weird syntax. So what we're going to do is I'm going to take a full project export of this out of 4.1, and I am going to import that. This is 4.2. So this is going to do the migration and everything that would happen with your project. So when I come in, the first thing we're going to notice is when I drop into OPC inputs, that param is now at the top. So what we've done is we've gone through your configuration and said, hey, you're using a parameter in this input. We're going to create a new concept called parameter, and we're going to show you it here. And you look at the parameters tab, you can actually go in and you could add additional inputs, and you see this looks a lot like modeling because behind the scenes it kind of is. And here's the default value, and here's the line ID. And then it's used in the same way, right? So in here I'm still using it the same way. I have templating enabled, but in this case, since I'm not doing any kind of expansion, I was using templating for parameterization before. I can actually turn it off. I could leave it on, it doesn't hurt anything, right? But in this case, I'm just going to turn off templating. And templating continues to work as it did before. The difference is we've separated the concept of templating and parameters, so I can use one and not the other. So if I didn't want to use parameters, I could go delete the parameter and just define the template settings, and then when I read this, I get an array of all those values, right? So it's separating those concepts. But you can see the migration, no work to do. This is just the default value. If we go to the instance, we're going to see the same exact thing. So we've scraped the instance, seen that it takes a line ID, given it a default value. Again, I can turn off templating because I wasn't really using it. And then this is where it starts to get pretty cool. So in the mapping of the attributes, what we've done is, and it's easier if we go look at the side by side here. So you can see we had this string here. What we've done in 4.2 is we've actually parsed that string into something that looks a little easier to manage, right? Where the connection's OPC, this is the input, this is the index that we indexed in, and here's the actual parameter. So we know at this point that this input takes a parameter. We're going to show you that and then allow you to set it. And just so you don't think the configuration of this is the same in the sense that if I wanted to remap this, I'm going out to OPC, I'm going to Mixer. That was alarm reason. I'm just going to drag and drop, and you'll see we created that for you, and then I can go modify the parameter to be what it was, or whatever I want it to be in this case. So a much cleaner interface to discover parameters, right? I didn't have to remember it and write some obscure string. It's actually there for me. Expressions are still a little different because this is JavaScript. The biggest change we made here is we changed from the custom syntax string thing we were doing, which this would be comma separated if there were multiple, to JSON. So this is now a JSON object, which just means if you have special characters in the key names and the values, it's a lot easier to escape. It's a lot easier to manage now. All right, let's keep going. So namespaces. In namespaces, you're going to see a really similar experience. So again, before, where we had, we were kind of transitioning, we had this, we had a slightly different way to do it, right? We had this JSON here. Now we have that same kind of syntax. So we parsed that and said, hey, we know Mixer takes a parameter. Here's the parameter, and you can set the value, and it's different for both of these. And the good news is with all of this, when you do the test read, it just works, right? But now it's a much cleaner interface to be able to discover the parameters and be able to set those really easily. And the last place we'll look is in pipelines. So in here, you'll remember I had the read stage with the syntax. Now you see the same input. I can pass the parameter. I can set it to event.value something or do what I want, but it's just much cleaner. The other thing we've added that's worth mentioning here is if you go back here, I guess I don't have to show 4.1. So this is now the old read stage in 4.1 is now a read merge stage. The reason for that is this is doing more than just reading, right? You can define the event that's coming in. You can say, hey, do I want to inline it, keep it with a key, drop it? I can read multiple sources. So we refactored this to call this read merge, and then we've added a separate read stage that's much simpler for cases where all you want to do is read an object. So an event comes in this case, we grab the mixer, we set the value to, we'll set it to 2 in this case. And that's it. So event comes in, we could do this, right? Event, it's Friday, I can barely type anymore. Event value, line ID. So we could set it from something from the event too, but it's just much cleaner, and then a single event comes out that's the result of this read. So a little easier to do there. The last thing I want to show is that API piece. So we had that trigger, if you remember, that was marked as callable to be exposed over the REST API. So the way we've migrated that is we've actually decided that that should be explicitly enabled. So that switch is gone in the pipeline, and what you do is you add an API trigger. So if anything was more callable, it's going to get both of these triggers. One is to say, hey, expose this thing to the REST data server as an endpoint, and the new MCP server, which I'll show just in a second. And the other one is, hey, make this callable internally, so a sub-pipeline can call it or a namespace can call it. In this case, we don't need internal, so we're just going to delete that. And the other really cool thing we can do now is API and callable triggers take parameters. So I can start to more richly define what this interface looks like, give it a line ID, and say it's an int32. And now, if someone calls it and doesn't meet those requirements, it'll fail, right? It's not going to fail at this level where I'm trying to use that value. It's going to enforce it. So now in the REST data server, let me just clear this. If I execute, so I'm going to go interrogate the pipelines that I have. I might have not saved it. 1 second. There we go. Yeah, there we go. So you can see that line ID property is passed there. This is JSON schema, but it's using this definition to say, hey, this thing takes a line ID. This is the data type that you need to pass it. The other place we use that now is the MCP interface. So I'm going to breeze over this. If you're not familiar with MCP, there'll be separate videos. But when I connect to MCP now and list the tools, you can see that endpoint, which is exposed in 4.2, is there. Jumping around. And then, so get mixer API is there. And then the other important part is that line ID parameter is also exposed. And I can call it now and get the result for the different lines. So you can see just a much better overall experience. And the other important piece, I mean, the real reason we're doing this is we didn't like the custom syntax, string syntax. It was hard to manage. It was hard for people to understand and use. And the other piece is we're just seeing a lot more pull for kind of this concept of an API layer on top of the factory. And when when you are that as industrial data ops, we both need to be able to package up data and move it outside of the factory and into through pipelines and flows. But the other thing we need to do is that API endpoint, we need to respond to requests. And these requests need to be able to define APIs, right, that are rich, that include parameters and requirements, and MCP and REST data server using that. So this positions us much better to more richly define those APIs that, in this case, MCP AI agents are going to need to be able to interact with this data. So that's it. Bit of a long video, but obviously a lot to cover for existing HighByte users. Give it a try and send us some feedback.